Hello again. So this video is a couple of examples on graphing cosine transformations with some A, B, C, D values plugged in there. All right, let's say there's a 2 here. So my first equation, clearly you can see it's a cosine graph that I need to sketch. So before I start doing that, on the side, I'm going to tell myself that this is cosine graph. The parent of cosine goes like this. Parent cosine goes up to 1, goes down to -1, and fluctuates between the two. The period of cosine graph is also 2 pi, just like sine graph, which means going to complete one cycle in that time. Also, the cosine graph, so halfway through this is pi. The cosine graph goes like this. Here's a quarter, here's 3/4, starts off at 1, and then finishes off also at 1 at the very end. Then smack in the middle is when it reaches its minimum value, and then passes through the first quarter and the third quarter. So here, and then comes down to minimum, then passes through the third quarter point here, and then reaches its maximum. That's the basic shape of the parent cosine. Again, period is still 2 pi. If I were to graph sine also right here, be very careful, don't get confused between the two. Sine is stuck to the origin. Halfway through, it completes a top cycle, and then the other halfway, it reaches minimum here at the 3/4 sine, and then comes back here. So green one would be sine, and the white one's cosine. So for this one, I'm going to keep in mind that, hey, I'm graphing cosine. This is the basic shape. Like if you want to remember the shape like this, a little wine glass, if that works. So here I go. I'm going to identify a few things first. Also notice how the B value is distributed in. So the first thing I'm going to do is make sure that 1/3 is pulled out of the parentheses. So that'll be x, and then the second term here would be pi over 3 pi. This will become 3 pi. So be careful here, because the idea is when I redistribute it, I get 1/3 x, and then when I distribute a third with 3 pi, all I'm left with is a pi. So I'm back to the original question. I just double checked that I undistributed it correctly, or pulled out the GCF. So once it's pulled out, now it's time to identify ABCDs. Reflection, yes. A value is 2. B value is 1/3. So might as well go ahead and get P from there, because P is 2 pi over B, which is 1/3, and that makes it 6 pi. So this is a really slow wave. Frequency is 1/3, like I told you earlier. B is actually frequency. So this is 3 times slower than the parent. And hence it takes it 6 pi to complete one cycle, like 3 times the period of the original. Then comes in C. Now you identify C from here. C is 3 pi, which means to the right. So its starting point is 3 pi, the first cycle. And then D is 4, and then up 4. All right, given all of these, A, B, C, D, and P, I'm going to start my sketch here. First thing you want to draw is the midline. And the midline is the shift. In this case, it's +4. And now let's see how high this goes based off the amplitude, and how low does the wave go. Amplitude is 2, so this will go up to 6 and down to 2. It fluctuates between that. All right, scoot it to the right, 3 pi. So start point is 3 pi. Then I need to know the end point. And meanwhile, since I have the start point, I can go get my quarters started, or quadrants. First quadrant, second, third, and fourth. And I need to now know the end point. And for that, end point is equal to start point plus the period. 3 pi plus period is 6 pi, which is equal to 9 pi, which is the end point right here. So this one will be labeled as 9 pi. Once I got the end point, here's the midpoint. So what's right in the middle of 3 and 9? They're 6 apart. Half of that is 3. So it would be 6 pi. And then right here would be 4.5, which is 9/2 of pi. And here would be 7.5, like 7.5, which is 7. What was I doing? 15. So 15/2 of pi. So I got all 4/4. If 3 pi is where we start at, then clearly y-axis is to the left of it somewhere. So here I go ahead and declare my y-axis. And x-axis has to be below 2, somewhere here. And then here's the origin. So we have our wave with respect to the origin. And the last thing I need to do is put the graph together. It did have reflection. Keep the original shape in mind, the parent shape. Now I have to reflect it, which means lowest point, I start off at the lowest point, I end at the lowest point. Right in the middle is when it reaches its max, and then make sure to pass it through the first and third quarter. Here, which is the max. And of course, don't connect it as a straight line. And there. And that's one cycle of that cosine wave. I did reflect it. Between 3 pi and 9 pi is when it completes its one cycle. And if you see how the period is 6 pi, it justifies it. 3 to 9 is 6 pi. Yeah, scoot it to the right, 3 pi. Yeah, that's that. So I think we've done with the sketching of that wave. So the second example and the last example, I have something listed in degrees. We did reflect that. Okay, here's the second example for cosine. Again, identify its cosine, number 1. Number 2, if you notice how b is already pulled out, so I don't have to undistribute it or pull it out. That's how it should be. B should be pulled out of parentheses. All right, time to identify. Reflection, yes. A value, so the A value here is 1, amplitude is 1, just like the parent. That part did not change. B is half, so again a slower wave. It's going to be half as slow as the parent, which means its period will be 4 pi. So if I quickly do that, P will be 2 pi over B, but now we're in degrees. So 360 over half, which makes it 720 degrees actually. Keep, change, flip. So period is 720 degrees, which is 2 pi. Then comes in C, again to the right, 90 degrees to the right. And then D is down 1. Now that I have all these, let me also find the start and end point. But we already know the start point, which is 90 degrees. So end point is start point plus period, which is 90 degrees plus 720 degrees, which is 810 degree end point. All right, here's my midline, which is down 1, but amplitude is 1. Oh, so if you notice, it goes up to x-axis. Plus 1 and minus 1. So I already formed the x-axis. I'm going to just darken this line because I know that's x-axis. Here we go. All right, then comes in the start point, which is 90 degrees. If this is 90, then the end point, we already calculated, is 810 degrees. It's time to get the quadrants going. Halfway. And then quadrant 3 and 4. Got that. And what's going to be in the middle of 90 and 810? So the period is 720, right? Half of that is 360. If I take the start point 90 and add half it to it, 450 degrees. So this would be 450 degrees. And then half of that is 180. So if I take 90 and add half of that to it, 270 degrees. This would be 270. So what are we doing? Basically adding 180, right? Add 180, then add 180, then add another 180. 450 plus 180 is 13, 145, 456, so 630. And then if you add another 180, we should get 810. Yep, 810. So it works, 630. There's that. 630. I got all quarters going and all of them labeled. So all critical points labeled. If this is 90, then clearly y-axis will be to the left. And that's the origin, so that the wave is in perspective. And I do need to reflect it. Yeah, this is also reflected. If I change that, if I take the reflection sign away, just because the other one was also reflected. Okay, remember this is the start point, so cosine wave at its max, at the starting point, at its max, at the end point. Yeah, so start, max, end, max. Not right in the middle is when it reaches its minimum. And then don't forget that it's going to pass through the first quarter, then get to the minimum, and make sure to pass this quarter. That's why we're labeling them. And back here. And here's one cycle of the given equation. And I did change it to positive from negative, just so I could give you both. There we go. And of course, don't forget that this continues in both directions, but as long as we can get one cycle, we are good to go. Alrighty, see you in the next video. Bye.